Thank you very much. Yeah, welcome to the first session after lunch. I appreciate that you all are ready for your after lunch nap. Persons caught snoring will be excluded from the lottery at the end. Yeah, PowerShelling Active Directory, far and wide. Many thanks to our awesome sponsors, without whom we wouldn't be here today, or at least some of us wouldn't. I know I wouldn't be here today. My name's Evgenij. I live in Berlin, which could be guessed from my socials, both old and new. I used to go by CJ Berlin until they killed Twitter. Now I go by something else, but it also has Berlin in it. I've been in this business for over 30 years, 25 of which were spent in and around Active Directory, so learned a trick or two along the way. I published a book on Active Directory last year. I have one physical copy here with me, and one of you will hopefully take it home after the talk by answering one simple question and being the first person to give the correct answer. Right. Let's dig in. We have a lot of ground to cover. Full disclosure, I could talk about this for a week, so I'm just going to give you the highlights. Short motivation for this talk. What's wrong with the native PowerShell commandlets that we all know and some of us even love? Dealing with lots of objects, and by lots I probably mean more than anyone in this room has to contend with on a daily basis. If I'm mistaken, please bear with me. Maybe even you will learn a trick or two in the next 30 minutes. And oh, my timer is not starting, so now, there we go. To ensure I won't run out of time. And dealing with lots of endpoints for those of us whose Active Directories are more wide than they are far. And, of course, there will be things to take home apart from the book. Immaterial things, non-fungible tokens. Why are we talking about it? Why am I talking about it to a room full of people? This book, the subline of it, constitutes a wager that Active Directory will still be a foundational technology 24 years from now. I hope to live so long as to be able to collect on that wager. One assumption that might or might not come true is that medium-sized forests, like in 10,000 objects range, might indeed disappear and get migrated somewhere else. But the huge ones will remain for a variety of reasons, and so will the smallest ones, as red forests, and red forest is not dead. It also has not been deprecated, contrary to the rumors that are persistent on the internet. Microsoft is still using ESA technology. And this is corroborated by a LinkedIn poll that Linda Taylor from the Microsoft AD engineering team. There is an AD engineering team at Microsoft, and Linda Taylor has been very vocal in the last couple of months, years, engaging with the community, and she conducted this poll a couple of months ago, and the results speak for themselves. There are many forests that have users in millions, and domains in thousands, and DCs in thousands as well. So there is this tendency for AD not to go away, but maybe for the distribution of the forest size and complexity to shift a bit. What we'll be doing today, if you script for Active Directory, you always need to decide whether you will be working in AD or ADs that you know up front, so you know which domain controllers you will be connecting to, you know the naming context, you know where the OUs are and what they are called, you even know what the permissions are on those objects, so you could hard-code, we're not hard-coding things in scripts, but you could put stuff in configuration files that will remain unchanged for a long time. Or And this is what I end up doing very often right now, because I work at Semperis and I produce scripts every now and then. They have to run in a variety of Active Directory forests. So if you don't know upfront what expects you, then you will have to go through the whole thing of locating domain controllers, locating domains, enumerating sites, and so on and so forth. And for the sake of this talk, we will strictly remain in the first category. So I will be working against a known Active Directory. I will not spend any time on authentication. So I will be working from a domain joined computer, logged on as an enterprise administrator, so permissions are also not an issue, and I will just address the matters of getting a data. In that context, what's wrong with the AD module that Microsoft presented all those years ago? Nothing really, except for a couple of things. It uses ADWS. It does not use LDAP to talk to Active Directory. It talks to web service that is running on a different port, and that .NET application uses LDAP to talk to Active Directory. It could be that from where you're running your scripts, that other port is not even open on the firewall, so you're not able to reach ADWS in the first place, in spite of your client absolutely being able to reach AD as such on port 389 or 636 or the global catalog. It has its own performance behavior. It has its own timeouts. It has its own limitations, and the module introduces overhead on two levels. First, when you import it into your session, it does expensive preparation work, like initializing the AD provider. I don't know if any of you has ever used the AD drive. I mean, there are use cases if you want to use a quickie to just get an ACL of one AD object, you might end up using this get item from the AD drive and get ACL. But apart from that, there is not much use for that facility, but it still gets initialized every time you load the module. And then it also does a lot of post-processing for you when retrieving objects, whether you want it or not. It will convert every SID to its text form. If you're not interested in the SID, it's wasted CPU cycles and it's wasted time. But if not the built-in module, what else is there? Your favorite AI will probably suggest system directory services, like directory entry object in the directory searcher class, with which you can do searches against your Active Directory. Those are .NET classes. You will find them in the .NET framework. You will also find them in the .NET on Windows. And that's great stuff. There are a lot of additional classes in there that allows you to locate sites, locate domain controllers, lots of advanced operations. This is a very, very useful facility to spend time on learning. But it goes one level deeper. System Directory Services Protocols is the low-level LDAP implementation within the .NET framework, and this is the only one namespace in this area that got ported to .NET not running on Windows. So if you're looking to automate your AD from Linux or from Mac, and if you're confined to first-party code for doing that, then System Directory Services Protocols is your only friend, and we will soon see it's our friend as well. And of course, interested third parties have done some work on enabling us to talk LDAP directly to Active Directory and other directories. I picked out the PS OpenAD module by our very own Jordan Borian. it's cross-platform. The only platform you can't run it on is PowerShell 5 because it is only compiled against .NET. It has not been compiled against the framework. So, but you can run it on Windows, you can run it on Mac, and it doesn't have feature parity with the native module, but basic operations are there. So, now that we know which tools are at our disposal, it's the time to select the tool that we will be using going forward for dealing with lots of objects. And to substantiate the claim of dealing with lots of objects, I used the reference environment. I was not able to bring it here because, as you will see, this is not very spectacular. It's one forest consisting of 2 domains, but with only 1 DC per domain. But there are some objects in there. So we're talking about like 2 million users, 2 million groups, 15 plus, it's more around 20 million group memberships in that thing, which resulted in the NTDS DID database exceeding 45 gigabyte in size. So that's not the biggest AD I've ever worked with, but it's close. It's close. And runtimes and execution performance in that environment, I will only be presenting as numbers. Because we're still talking minutes and even hours for some operations. No point wasting time running it there. But keep in mind, those DCs were virtualized, but they were not resource constrained during tests. Each DC ran alone on its own Hyper-V host. So the environment I did bring with me is exactly the same, but it has a lot less objects in it. We're talking about like 300 megabyte DID size, 15,000 users split across 2 domains. So we will be able to see things finish in this environment. Right now, the DCs are running on Hyper-V here on this laptop, so the performance is not predictable. But for the sake of the data gathering and performance evaluation, I migrated those same VMs to, again, separate Hyper-V hosts and ran the test there. So let's establish some baseline. I listed some tools. So we want to pitch the AD module versus system directory services versus protocol, and of course versus PS OpenAD. The comparison will not always be fair because PS OpenAD only runs on 7 and the native module only runs on 5, and even if you do execute it from 7, it runs in an implicit remoting session. So there is some unfairness in this, but let's have a look. So there we go. Simple as that. My breakout from the ISE. Here are my 2 domains. I will be doing enumerations only against 1 domain in the forest. And what I will be doing is just list all the groups. List all the groups I have in this OU tree, in this lab tree. So there are lots of sub-OUs, and in each of them there is OU group, named group, and in that OU there are groups of different classes, and we will just list them up and see how long it takes. So, Get-AD group. For fairness sake, I included the import of the module in the measurement. So, Get-AD group, filter star, because we do want all of them. Search base is the lab OU, and sub3 is the default search scope here. Then I will be doing the same thing with OAD, PC OpenAD, and then we will look further. So let me copy this to my clipboard, running this in PowerShell 5, and we counted 8,000 groups in 3.3 seconds. All right, let's do something else. Let's do OpenAD. Same thing, but we will be running that in PowerShell 7. Took half of the time. What else is there? System directory services. So what we are doing, we have this path variable that is our starting point, search base, and we are creating a root object using the ADSI decorator for these path objects, and then we initialize a directory searcher. It starts at search root. It has a subtree search. We're expecting more objects than our page size. So we set the page size to 1000 explicitly to have it return more than one page of results. And we are only interested in the distinguished name. We couldn't influence that with the first two modules. They would always return more properties than what we're interested in. In this case, we can influence that. And we are doing that by only specifying the one property that we want to find. And then we want to find them all. ds find all, we get a result set, iterate through that, and add every distinguished name to this list. It was a generic list of strings, same as in the first two examples. Let's see how we fare with that. I will run that from PowerShell 5 first. Half a second. That is much better, even in the small environment. Let me see how we fare here. Less than half a second, although the first measurement is usually not very precise because there are warm-up tasks going on the domain controller, but I will show you averaged numbers after we've done with looking at the code. So, and the last example is directory services protocols. And this is where the code gets really ugly. This is where it really gets ugly. But you will see it's worth it. So you have to add the assembly explicitly. It is not added implicitly when you start accessing it. So first order of business, you have to define how you are connecting to the directory. So if you're scripting for unknown forests, then the whole DC location stuff comes before that. You need to query DNS. You need to determine what your DCs are, what your domains are, what your sites are. Try to find the closest and whatnot. But now in this lab, we know where our DCs are. We're connecting to one of them. Then we're initializing a LDAP connection using implicit authentication negotiate, which in this case will end up being Kerberos. If you're unlucky, you end up doing NTLM. But that's up to you. We're setting the protocol version to be 3. Active Directory is able to speak LDAP v2, but there is no point in doing that. And then with these values, we have enough information to bind. Binding to our Active Directory, and then we create a low-level LDAP search request. Starting point is our path, our lab OU. We will be doing a page search because we're expecting more results than just 1,000, and which is why we need to create a page result request control from our page size, and that will be added to our to the controls property of our search request. Then, of course, we have to do a filter. Object category is group, and then here's an infinite loop. We're doing a page search. We always do an infinite loop and break out of that in the middle. Once the domain controller tells us there are no results to process, or you can do an early breakout. If you're looking for something, for example, for the first 10 occurrences of something, and you get the 10th from the second page, there is no point in iterating through 800 more pages, right? You can break out after the second page and be done with it. So, again, infinite loop with a breakout in the middle. And the way it works is you send a request, you get a result, and the result has two properties to it. The first property is entry, where you get the actual search results, and the other property is controls, and the controls property will contain a cookie. And the cookie is something that allows the domain controller to know where what was the last item it delivered to you. And then what you just do is, if that cookie is not empty, you just assign the returned cookie to your search request cookie and repeat the search. That's all you do. And by assigning that cookie, you just get the next page. That's all it takes. Of course, you would want to put this into a function. And for the outermost level of your searching, there's nothing wrong with putting that into a function. But if you need to repeat these operations for every item that's got returned, I would strongly advise not to put that into a function, because entering and exiting the function, especially if you do an advanced function, that will eat up all performance benefits that you might derive from using the protocols. You could use a simple function, because that's just a code block. That is usually okay, but do not use an advanced function within a fast spinning loop. So let's see if all this was worth the hassle. And in this small environment, let's start in PowerShell. Yeah, well, it's a bit faster already in PowerShell 5. And where's my 7? Here's my 7. And in the 7, we're down to 0.3 and something seconds. Okay, so a bit of ugly code can go a long way if you're dealing with a system that speaks LDAP to you. These are the results from the reference environment. Now we're talking about completely different kettle of fish here. The native module ended up being faster than Jordan's not here, right? Yeah, okay. But I told him that already. It didn't end up being faster. It also did not end up consuming more memory than Jordan's module. So Jordan's module loses at this point. But the directory searcher, in spite of being faster, it still took a lot of memory, because it doesn't do a page search. It does do a page search under the hood, but it returns the results in an internal sort of way that consume more memory than the page searches do. And here's one benefit that you would gain by running this stuff in PowerShell 7, at least 7.5.1, which is what I done. Despite taking a couple of seconds more time on the average, we saved on memory consumption simply by running that same code in PowerShell 7, because we're not using implicit remoting here or anything else. That namespace was compiled for .NET. It is native to 7. All right. First thing first, before you start optimizing your PowerShell, do look at your LDAP. Do make sure that your LDAP is not slowing you down. There are many things you can do wrong. Here are the highlights. If you do a far-flung search, searching over a huge number of objects by unindexed attributes, you've lost already. Most notably, your ChatGPT will probably suggest something with object class. Object class is unindexed in AD unless you make it indexed. Object category, on the other hand, is an indexed attribute, so object category searches will tend to be a bit faster. It's not the end of the world, as we will see in a couple of seconds, but it is faster. Too many attributes returned. Values you don't need, just don't return them. Unless you intend to use them at a later time, then it might be worth the while to return them, cache them, instead of doing a second search. But for a once off, if you request too many attributes, it will slow you down. Closed nesting doing ugly code with many, especially if you're searching for two attributes that are both indexed. If you concatenate them by AND, then the indexes get overlaid on the domain controller. If you concatenate them by OR, then of course it's two searches. Bitwise AND and OR on indexed attributes. So if you're searching for an indexed attribute but are only interested in one bit, it could be easier to actually search in a huge environment. Could be faster to search for the whole value and then process that. So let's see how much impact that indexed versus unindexed does have. There we go. We will be doing a very simple thing. We will be using protocols all the way down. That's the only thing we will be using starting now. So I have for each user in this subtree, I added 4. Is it readable? Can you divine in the back what I'm doing here? Let me see if I yeah, there we go. So let me scroll to the right place here. So I have 4 attributes here, starting with PSConf, and they have all the same value in each particular object. One of them is integer unindexed. One of them is integer indexed. The third is string unindexed, and the fourth is string unindexed, and they have values between 1 and 100. So, getting a random value between 1 and 100, and doing a search using object category by an unindexed integer, by an unindexed string, and so on and so forth. And then we will compare the results. And I will be doing that from PowerShell 7, because as we know, it's the fastest. So there we go. The results in this small environment are not very groundbreaking, but the ratio is. And the ratios in my experiments ranged between 8 times and 80 times. So depending on your search, you could be done 80 times faster if you stick to indexed attributes, or if you start indexing attributes in your schema. This is what ended up happening. Just ignore the lower table. This is just for reference. But those are the times we're looking at. Finishing in a second versus finishing in a minute and a half. So that's what we're looking at here. All right? So, in dealing with paged results, you of course have to know the effective page size. Page size is not always 1000. It's only 1000 by default. So if you don't know the environment you're working against, you might encounter lower or higher page sizes. And to compound insult by injury, the page size is not universal. It is not necessarily set for the whole forest, and you can't get it from root DSA. You need to establish the policy that is applied to your particular DC you are working against. I will upload a scriptlet with the session materials that shows you how to do that. Yeah, but actually, just knowing that the default query policy has a page size of 1000 in it doesn't tell you that the DC you'll be working against does. And I've seen creative administrators do weird things in the past. Be mindful of your RAM usage. You saw that. So if your client where you're running your scripts is constrained, then RAM usage translates into RAM paging, translates into disk activity, translates into slowing you down. So paged searches help you not only speed up and to do an early breakout, but also if you're not caching the page results, it's also helping you to restrict your RAM usage. If you are required to cache your results and you have lots of them and you have to reuse them over and over again, consider using an external data store. Consider using SQL or a SQLite or something. I did a talk on that in Vienna, I think, or in Prague. No, it was Vienna. You can even run SQLite in memory and dump it to disk afterwards. Whatever you do, bring it out of your PowerShell session. So, the area where it gets really interesting is calculated properties, also known to some as constructed attributes, and they are calculated by virtue of being calculated at the moment you actually access them. They are extremely useful. They are there for a reason. Things like token groups. If you want to know which groups a user or a group belongs to, token groups is your friend for an individual user. We will see that it's not always true if you need that universally. MSDS member of transitive is the inverse of that. Parent GUID, if you want to know what container your object is in, that's your friend. Resultant PSO, resultant authentication policy. All these things are computed at runtime, but all of them require a base search. To access those values, you need to search, to do a search across the particular object that you're looking at with a scope of base. Only then these calculated properties will be calculated, which means if you do that for every member of a large search result set, you need to iterate through them. And this is an unsolvable problem in huge environments. Calculate or determine if you have looped group memberships. Any people here who are French or are working for a French company? So your governing body in terms of cybersecurity is ANSI, and ANSI specifically requires that anyone doing an Active Directory security check also looks if there are looped group memberships in that environment. They say it's because some tools that would iterate through group memberships get confused if it comes all the way around. But in my testing, it also introduces a performance penalty on domain controllers, on group searches. I wasn't able to quantify that yet. Blog post incoming in a couple of months. How do we approach that? We could start building trees, basically reading the member attribute and building trees locally. Or we use member of. Member of would be better because member of, by default, by definition of that, will only contain groups which we are interested in, whereas member will contain groups, users, computers, and other sort of objects that we would have to exclude by some means. Or we use token groups. Token groups exists for groups too, not only for users, but it only contains SIDs, not DNs, which means we will have to translate them from byte array to some other form. We could use the in-chain LDAP control, and that's my intuitive go-to. LDAP has this in-chain control where you can say, yeah, I'm looking at member of, but I'm looking not only at direct memberships, but at nested memberships as well. And then we just look whether the group is an in-chain member of itself. Could do that. And we could use MSDS member of transitive, same thing. And I will not show you the code. You'll get it. You'll get it from the PSConf repo. I will only show you the results. In-chain, that was for a small environment. In-chain was the exact right hunch. It finishes first. It has the least resource consumption on the client side. It has moderate resource consumption on the main controller side. These things in the reference environment did not finish in 3 days. And during I did run that for 3 days, each of them, and the LSAS process consumed like 75% of CPU and all of the available memory on the domain controller. They still would answer requests, but barely. Imagine doing that in an environment that is in production and has to serve your whole organization. In addition to that, there is a bug to member of transitive and member transitive. This is a bug Microsoft is refusing to fix. The bug is at a very low level in NTDS. And this is it will only surface in a huge environment. If your member of transitive returns more than 4,500 results, you only get the first 4,500 of them. There is no way around it. People tried ranged retrieval, people tried ASQ, people tried all the things. This thing is broken if you expect to get more than 4,500 results. So this is the start of one of the executions. It starts innocuously, and then after 34 pages, we have like a runtime for a page for 1,000 results of like 835 seconds. And that did not, it did saturate at the end, but at a value that is not of interest to any of us. The results, the 12 groups that have been found are solid. So those are the 12 groups that had nested, looped nestings in that environment. So if you were only interested in determining whether there are nested loops or not, you would have finished very early. But if you want to actually know which groups those are in order to go and clean that up, then of course, yeah. So what did work, I did bring it to finish once. It's injected, so basically building trees locally. We're back full circle to building trees locally. Inject this stuff, direct memberships into SQL. That took 4.5 hours to do. SQL running on a different machine. Unconstrained, but loaded. And then running an evaluation over that database. So I'm not a data wizard. I think there are at least 100 people in at this conference who would have done a better job than me. But my naive procedure finished in 3 days. So it was able to produce a result in 3 days and 4.5 hours. Which brings us to the question, what if I want to do the same thing again next week? Then probably, and the idea to speed that up would be using a native vector, native graph database. But I didn't have time for that. Blog post coming. Small changes in a big data set. So now I know what my nested looped nestings are. How do I determine that next week? Of course, I would like to do a differential search of some sorts. The recommendation in the SDK is change notifications, but that requires a constant connection. That's not a good fit for scripting. That's a good fit for an agent that is running constantly. That's not a fit for scripting. If you have DC sync rights, you could do a DC sync with a cookie. Requires you to reconnecting to the same DC every time, but I mean for that task, that would be a good price to pay. You could look at replication metadata. It is not going to be faster than anything because there is a lot of translation to be done there. And you could look at USNs, but again, USNs are stored per DC, so you'd end up reconnecting to the same DC over and over again, but again, you could. And USNs is what I ended up mostly using in the past. So, one last thing, I am mindful of time, so that we have time to determine the winner of the book. But this is important because everyone has heard about bad successor, right? So permissions are not an academic matter anymore. Permissions in your directory are vital for the survival of your company. So, how do I process permissions in a huge environment? They are stored in a binary form that is derived from a text form from SDDL, Security Descriptor Definition Language. The usual way, what your ChatGPT would probably come up with, is by using security references. And that is the last thing I wanted to show you, because security references do have a performance penalty to them, because Windows will evaluate them every time. So the objective here is to find all objects that are assigned ACLs, assign any permissions by a certain user. Right, so I'm retiring a user and I don't want like orphaned ACEs, so I want to know where this user was granted permissions to. So the user is Joe user. And then what I'm doing is I'm creating an identity reference for that guy. I'm retrieving the entity security descriptor from every object in the tree, and then I'm reading it into an Active Directory security object, which is the default way to do that. And then here is this property access. It's calculated on access, and that is the visual representation of your access control list. And then I scroll through the access rules and see where the identity reference matches the identity reference of this Joe user. So let me run it to get, I have to run it in 5 because for some reason it doesn't work in 7. So, and it will find eventually some stuff. But does anyone here know what else is happening when I resolve an identity reference against Active Directory? That accounts for around 10% CPU on the client that are getting consumed while you do that operation. But what else is happening? When I run this code, and I'm using the native AD commandlets to make it easier for you, what happens after I run this, except that the user will get created? And this is important. If you learn nothing else, it was still worth the while to be here. No one? All right, let's run it. So, I did create the user, I did obtain the identity reference for that user, and this user was created just now. We can be absolutely certain, see, you're not even seeing it. Here it comes. But, if we look at the attributes, last logon time step, it performs a Kerberos S4U to self operation, which means the last logon timestamp gets updated, which you use to determine which users are inactive in your environment, and this user wasn't active ever. And it also evaluates the token. It creates the complete Kerberos token. So in my reference environment, this Joe user is a member of like 5,000 groups. When you do that against Joe user, it says, no, token is too big. I can't log you on. I wasn't trying to log you on. I was trying to determine what your net bias name is. Yeah. So keep that in mind. Operations that don't seem to have anything to do with logons and stuff might trigger that behavior. So there is a better way, and I will show you the results. by just using SDDL. SDDL is a string, and PowerShell is great at matching strings using regex, and Matthias over there is a regex wizard. So if I'm just in the business of determining where Joe user what has been assigned permissions, I just download the SID, convert it to text form, and match Joe's SID against that. And then I get my results even in the reference environment, where it took, as you can see, there is almost no overhead in it. Just assigning the text form to a variable took the same amount of time as performing a regex match against each item, and it took almost 2 hours to do that by evaluating the identity references. So we'll skip through this. There are reasons for dealing with lots of endpoints. For example, if you want to do last logon instead of last logon timestamp, as we know, it's more precise information. Audit policy, security policy. I will supply a couple of examples with the code from the talk. Things to take home. Think twice before you LDAP. Use protocols. Be mindful of local resource consumptions. Look at ASQ searches. ASQ searches is a great feature. Just look it up and try to educate yourself. Computed attributes should be avoided if possible. Learn SDDL. Learn SDDL. This is a great thing to know. In loops, optimize to the max. For many endpoints, work in parallel and be mindful of the AD module doing preparatory work if you import it in a lot of namespaces. So now is the moment you were all waiting for. That's why you're stuck with me. Oh, and I come prepared. I actually prepared the question. It's quite easy. What is the first party library called that allows accessing Active Directory from a Linux or Mac OS machine? Where was the first? System, Directory Services, Protocols. That's the right answer. Oh, SDSP. If you want it signed, hit me up. If you don't want it signed, you can have it now. Thank you very much. Are there any more questions, by the way?